All right. Hello, everyone. Welcome. Really excited to be here talking about machine learning. I know many of you heard more than 60 minutes of new launches in Andy's keynote today. So my goal here today is not to actually just go through a repeat of what Andy did, but it is to actually pick a few of these new launches that we did and show under the hood look on how these things work, why we built them the way we did, so that you get better insights into how they work, how you can use them, how you can leverage it. And also, I'm excited to bring Jillian, one of our customers as well, to see how they built an application for their enterprise use cases, one of our launches today as well. So with that, let's get started. So machine learning, one of the common phrases you would hear constantly in Amazon is that we are in a golden age of machine learning, where it almost is like, I don't know if any of you have read the history of Renaissance in the art world, but it's almost the same thing is going on now in the machine learning and computing world, where there is so much innovation happening. But the thing is, these innovations are not tied down to like one area or one technology, but it is starting to actually show up across multiple different industry segments. But one thing to remember is that machine learning technologies are actually not new. So many of even some of the, arguably one of the predecessors for deep learning paper was written like 30 years ago. So why did it take us so long to actually put these things in practice? And the biggest reason is historically they were very, very hungry for compute and very hungry for data, and they were not really accessible for everyday developers to actually put it in a real-world application. So as cloud computing made compute and data really easy and readily available, and as the machine learning algorithms and frameworks started getting more developer-friendly, we started seeing an explosion of adoption in the past few years in AWS. And one of the interesting things is, unlike many disruptive technologies, which usually tend to have affinity towards one or two industry segments, in machine learning, we are seeing adoption in almost every industry segment. For example, Thermo Fisher is actually using Amazon Forecast to predict and optimize inventory planning. NASCAR is using actually our services like Amazon SageMaker and Recognition to do things like automated video cataloging for enhancing metadata and captions and so forth. Intuit is a financial services company in US. They are reimagining many parts of their application and customer experience using machine learning. And they built actually amazing machine learning driven application called Expense Finder, which will automatically detect and find all your expenses, let's say 1 year worth of expenses in a few minutes. And their experience has been that their time to build machine learning models came down from like 6 months to less than 1 week using some of the tools Andy touched on. So, and you heard from Sun, our CEO today, on how they are reimagining healthcare with some of the tools like SageMaker, Transcribe Medical. Well, one thing actually, one of the cool innovation that they did is that they actually built a machine learning model for predicting congestive heart failure, where the model actually predicts 15 months in advance of actually even what a regular practice would do. That is the potential of machine learning. So much exciting possibilities ahead. But the interesting thing is, as much as we see so much adoption, I happen to believe we are still in day one with respect to machine learning, because the journey has just begun. Even with all this adoption, we are continuing to see people are just scratching the surface on the impact of machine learning. And as an industry, we actually face a few major challenges on making it cost effective, making it easier to train, making it accessible, and so forth. And as we were chatting as a team and actually saying, like, what are some of the other technologies that went through such a transformation where, like in machine learning, if you see, even nowadays, but not so much, but at least even a year or two ago, you had to have like PhD in machine learning to build advanced machine learning models. And you had to have so much expertise, spend a lot of time and so forth to build it. And we were asking, what are actually examples of similar such technologies in the past that have gone through this transformation? And one of them actually we found was actually photography. So if you look at it, during the early days of photography, it used to be that you really one would need expert skills, and they would need a lot of time and really hard to use equipments. And it'll take them actually multiple hours to take one good photograph. I mean, that used to be the case around like 1826. In fact, I think the first photograph was taken around 1826, and it would be like 150 years later that we even invented professional digital camera. So I'm sure at least some of you would remember, even in my lifetime at least, I remember actually even adjusting things like white balance and f-stop and actually taking these pictures to develop the film roll and find out that half of those film rolls were either overexposed or whatnot. So, but now, if you look at the photography industry, this is what is going on, where digital cameras have become actually the most pervasive. I mean, if you look at Instagram, everyone is a professional photographer, right? So, in fact, my 4-year-old daughter takes better selfie and takes better portrait pictures than I do. So that is really how much the technology has come. So we always ask ourselves, as Andy said it, how do we make similar transformation to make machine learning in the hands of all developers? Because we are still ways far off in actually putting it, and our fundamental mission is to make machine learning in the hands of everyday developers, not just folks who are expert practitioners with advanced degrees or PhDs in machine learning, but aspiring machine learning developers who want to build machine learning models to do personalization or forecasting, or application developers who say, all I want to do is do enterprise search. I don't want to deal with actually understanding what is a natural language understanding model is and how do I integrate all these things. They just want simple, easy-to-use APIs. And the crux of my talk is around like the 3 challenges that actually stands in the way for making this happen. So as we work with more and more customers, while they've been giving us feedback saying like, hey, you guys have been doing great in terms of helping us get started with machine learning and adopt it at scale, but we still find there are areas where either we have skills gap. When we are trying to build machine learning models, not enough people can build machine learning models. And then the second thing is, it is harder to scale machine learning practice because the process of building machine learning models is still time-consuming and an expensive process. And the third one, which is actually equally important, if not more, is that especially I hear this from the CIOs and actually the leaders of companies, is that they find it hard to figure out what is the right business use case and problem that could benefit from ML. They almost say, like, as Andy called out in the contact center analytics, instead of just giving them building blocks, they say, why don't you integrate and make it easy for us to understand? So this is kind of actually the way we thought about it as we were launching it. And our machine learning stack is kind of in a 3 tiers of investment, where at the bottommost tier, we are actually making investments in providing technologies to make developers easier to build machine learning models. And the middle tier is the SageMaker one, where it is super easy to build, train, tune, and deploy machine learning models, especially with SageMaker Studio. It is like, again, a step change in how easy it is going to be. And the third one is how do you easily apply. So for the rest of the talk, what I'm going to do is just pick a few key innovations in each of these stacks. How are we doing it in terms of how do we make it easier to build, how do we make it easier to scale, and how do we make it easier to apply? So with that, let's start with the part 1 on how do we make the process of writing machine learning models and applications easier to build. So one of the first things many of you would notice in the machine learning industry is today, Python is by far the most popular way to build any kind of machine learning application. In fact, more than like 70% of machine learning algorithms and other things are written in Python, and it is only increasing. But if you see, as an enterprise, there is still a huge portion of people who actually still rely on Java. In fact, Java has been a #1 language since like 2004, and it has like greater than 67% adoption in enterprise. So we have been hearing feedback from developers, both internally and externally, saying like, how can you bridge the gap? Because what this essentially led in many everyday enterprises are that there used to be a data science team which actually built all these models, and they will build it and then hand it off to the enterprise IT team, which will operationalize it, which is such a strange barrier or dichotomy. In fact, there should not be that much of a barrier in terms of innovation between these two. So that is one of the reasons why we launched this week DJL. It's a deep Java library that gives a simple Java API for streamlined workflow and actually building deep learning stack. It works on both MXNet and PyTorch, and it has native bindings. But the cool thing that I really liked was it was very easy for prototyping, because it already includes a bunch of certain pre-trained models for common machine learning problems. So it's very easy to get started. And soon, it'll also have things like autopilot as a native feature. When you think about it, like AutoML capabilities as a native feature. So it's an easy way to get started in terms of if you're a Java developer who are excited about machine learning technologies and want to play with it. And when we talked internally to some of our teams, such as Amazon forecasting team, this is the team, if you're in US, I don't know how many of you ordered packages in Amazon for Black Friday or Cyber Monday, but this is the team that actually predicted in which part of the city who is going to order what so that you will get your packages in 1 or 2 days. So this team, they actually was giving us feedback like, right now they have a data science team that develops forecasting models in terms of what are all there. For example, Instapot accessories that customers would want, which is not the, let's say, top 100 popular items, but it might be one of the long tail items, and that's what forecasting is super important for. And then once they build a model and however they build it, and they actually hand it off to the Java infrastructure team, and they actually go and operationalize it. Now with DJL, they expect this time to be save up to like 30% in development time. So this is actually a big savings when we are operating at the scale of like Amazon forecasting team, let alone Amazon. But Java is only the beginning. What is more popular than Java in any enterprise or among any developers? It is SQL. So we asked ourselves, saying like, how do you actually make the process of building machine learning driven applications for SQL developers easy? So let's ask the question on like, what does it actually take to incorporate machine learning in a database-driven app? So let's talk through this example. Imagine I want to build a sentiment analysis application where I'm actually building a content review board where I'm getting customer feedback and so forth, either from Twitter or from my web forums, and I'm putting it in an Aurora database. And now I want to actually build a dashboard of all the positive and negative sentiments around the feedback we have been getting from customer. The typical steps require something like I select and train an ML model. Let's say you actually build your own or you use even Comprehend. And then you write an application that queries your Aurora database and actually gets the record and then formats it in the right manner and then sends it to your ML model. And then you are actually calling the ML service and getting the output and then reformat it for your application and then load the results into the app. Well, each of these individual steps for ML experts might be, hey, this seems not too bad, or database experts, it would be like not too bad. But a simple, like a sentiment analysis application might end up effectively taking like at least a few weeks, if not like a few months worth of project. So that is one of the reasons why we asked ourselves, how do we actually change the landscape here? So today we are launching the availability of machine learning integration into database developers and BI analysts. So that means from an Amazon Aurora database, you can actually, using native SQL queries, you can call SageMaker, or you can call Amazon Comprehend. And from Amazon Athena, you can actually call SageMaker models. And from QuickSight, our BI service, you can build a dashboard without even writing a line of code. So let me show you how it works. Now, I touched on having 6 steps and why this is such an manual and intensive process that is not actually as good as you would like to be. Now, with this launch, what you're going to get is from 6 steps, you effectively condense it down to 3 steps, where optionally you can actually build your own model. Again, you can do that with SageMaker Autopilot, so you don't even need to hire a data science team. But, or you can actually pick like Comprehend to do like sentiment analysis API. That's your optional step 1. So if you use Comprehend, then it's effectively, there is no step. You can skip to step 2, where you run a SQL query and then use the results in an application. So let's take a look at some examples. Here is an example of like the kind of SQL query you could run from an Aurora database. For instance, finding suspected fraudulent transaction. It can be as simple as these are the kind of queries you could do in predicting which are the fraudulent ones. And to flag comments with negative sentiment, it's really as simple as select from this table where the comprehend sentiment detection for this text is negative. Think about it. So what used to take like multiple weeks now is a simple API, a SQL query. So, and sort queries by predicted future sprint. Again, you can integrate it with your own customer ML model. So this is how it this is how you can use it. Now let's take a look at how it actually works underneath the cars. So under the hood, now you write an application that queries a database. And let's say the Amazon Aurora database has a table, something like product reviews. So now let's take a look at a customer issuing a query like a select star from the table, where they want to actually identify all the positive feedback. Now the Aurora query processor gets this request and quickly realizes that, hey, this actually is integrating with an external service, such as Comprehend. So the query optimizer now gets flagged, and it fetches first 25 rows and actually calls Comprehend batch API. Instead of actually doing 1 row at a time, now it is trying to save not only the cost, but also improve the throughput and latency for the SQL query by calling first 25 rows at a time and returning the response as it iterates through. So it has 50 rows here. So once it is done, it actually responds back with the result. And it's pretty much as simple as that. So now, I won't go into the QuickSight analysis, but what is more popular than actually SQL? It is not even writing a line of code. So that is exactly what you can do with actually the QuickSight and SageMaker integration, where to predict a customer churn dashboard, all you have to do is pick a data source and then actually visualize it and mark a prediction column. And there are model marketplaces available where for customer churn, or you can actually pick an existing one, such as Comprehend or others, or you can actually do your own as well. So that's on making machine learning easier to build. Now let's talk about how do you make machine learning easier to scale. So today you heard Andy talk extensively about how so many companies are standardizing on SageMaker, where they are actually making the machine learning model development process effectively, the time it takes to build ML models is significantly dropping down. And our customers have said, hey, the SageMaker has really brought down the development time. But one of the consistent feedback we heard, and that formed the hypothesis behind all our launches today, is machine learning development is not as easy as software development. Because If you're building software today, one of the things you'll notice is you have like really amazing IDEs. You have easy ways to actually compile and test and write unit tests and actually debug before you even deploy. And once you deploy, you have profiling tools. And then you can actually still monitor and alarm in production. So you get all these capabilities. And if you look at the machine learning, historically, this has been much more of a black box. And one of the biggest and that is one of the reasons why we launched SageMaker Studio with all these capabilities. But among all these black box, the biggest one is around algorithm selections and picking the right machine learning model for this problem. If you look at why this is challenging, historically, this is because to build a machine learning model for something like a classification problem, it is a largely explorative problem. You actually have a data set, you have to pick what are the right set of features, and you got to actually also pick what are the right set of algorithms to explore. It can be a linear algorithm or gradient boosting or actually neural nets, and it requires a broad and complete knowledge of machine learning domain. And the thing is, it's not just the picking the data pre-processing features and the algorithms, it's also all the variables that goes into optimizing these things. So it becomes like a big combinatorial exploration matrix. And that is one of the reasons why this process has been incredibly long for many companies. And AutoML has been a very popular topic across the entire research community. And you see many solutions. But even though we could have launched something even much sooner, one of the things I fundamentally felt is that just launching a black box AutoML is giving customers a false choice. Because effectively, you're telling them, if you actually, either or you should do it yourself, where you effectively require a lot of manual effort by experts, and they get the benefit of fully controllable and auditable, and they get to make the trade-off decisions between, I would rather pick explainability so that I understand what algorithms you used, or actually how you optimize for latency or model size instead of just accuracy. I get all those controls. So do it your own sounds actually pretty good if I want that control. But if I'm willing to sacrifice all that control, then I can go trust a black box where it picks everything, and it gives you one model, and then you're done. So, and we said, we should do better than this. And that is one of the reasons why today we launched SageMaker Autopilot. Effectively, you don't need to have this choice between a black box versus do it your own. With SageMaker Autopilot, you get an integrated experience. I, as a developer, now I can pick my data set. Andy talked about the house pricing as a data set, but you can pick any other kind of data set and actually upload it in S3 or in SageMaker Studio. You set a prediction target and pick regression or classification examples, or you don't have to pick anything and we will automatically figure out. It does automated feature engineering, automated algorithm selection, and HPO. But the most important of it all is it first, right away, gives you a commented notebook where it's effectively giving you a source code on what it's going to do. So there is no black box as an user. I know precisely what the system is going to explore. And at this stage, I can actually even decide if I want to do something else different. So let's go deeper under the hood and see what it does. So to begin with, I, as a developer, give a tabular data source. And then here, it actually starts with the exploration in terms of what are all the data I should be doing, what kind of encoding I should be using. It provides a bunch of different encoding automatically and whatnot. And then, as a next step, it actually generates a candidate notebook of all kinds of algorithms it's going to explore. And this is where I, as a developer, can say, hey, I mean, these algorithms make sense. Or I can say, I would like you to add these set of algorithms as part of your trial data set. This way, I'm going to actually influence and have more control on what I want. Or I might even decide to say, I don't want you to explore algorithms where I cannot explain or audit what's going on. Because some cases, there are regulated industries where they might say, I should be able to explain in a very simple manner what's going on. And you might choose to actually pick certain algorithms that that can only be done that way. So with that, now once the candidate notebook actually you're getting and then kickstarted, the next thing it does is it kickstarts a bunch of trials. In this case, let's say up to 7 trials. And each of these trials effectively spawns off like huge number of model training jobs. And each of these training jobs go through like a Bayesian optimizer and many other bunch of model optimizer functions to go and build this out. And now, after all this, you actually effectively get like a score of various different models, how they are performing. So with this, now I, as a practitioner, get to make a trade-off where I don't get one model. I actually can pick across 250 models, but typically we return up to 5 to 20 models. For example, in this example, if I'm building a customer churn, where I get like a bunch of the top 5 models, such as XGBoost with different kinds of model optimization. And here are the accuracy and latency and model size characteristics. So once you get a leaderboard, you get to make the trade-offs. Let's look at a simplified version of what this means. In your standard black box approach, your answer is always going to be your first one, which is, I get the best accuracy, 95%, good to go. If I'm happy to live with, let's say, an increased model size or actually increased latency of 450 milliseconds, I'm good. But if it doesn't work, I had to take charge and do something else. Whereas here, if latency is critical for my model, I might be OK with the taking 2 points decrease in accuracy. That is a choice you as a developer get to make. And that is really what Flintstone or autopilot enables you to do. So, and with this, I'll actually quickly touch on also a few other things on SageMaker. So in terms of what are all the other things autopilot enables. But the key thing I want you to take away is there is a lot of discussion, if you see as an industry, around explainable AI. So, but the key things actually you want to think about when it comes to explainable AI is ask yourself what are all the black box approaches you end up subscribing to and start to unpack each of them. So that is super important. The moment you understand what is your system trying to do, what is the kind of data you're trying to feed, how does it diverge from the real world, and then so that when to retrain it, and if you have access to the end-to-end source code and the statistics of the data, you have the most control. So that's kind of what autopilot enables you to do. Now let's talk about once you build the models, you have to take the models and go from model building to production. So to go to productionable ML workflows, here is where you need repeatable workflows. This orchestration typically tends to span IT boundaries, and data scientists usually prefer traditional or a familiar language to build and orchestrate workflows. And in the past couple of years, you've seen a lot of new orchestration frameworks, such as Kubeflow, Apache Airflow, and SageMaker step functions did their own, and MLflow, and so forth. But the reality is, while the frameworks are good for orchestration, but orchestration is not enough. Customers still need to provision training clusters. They still need to make sure the training clusters are up and running, and then stop them when they are done, and all these things. So that is one of the reasons why our customers are saying, like, we really like these frameworks. I would love to be able to integrate SageMaker natively with these frameworks. And that is one of the reasons why this week we launched the support for Kubernetes operators with SageMaker, where you can actually train and tune and deploy models from popular orchestration frameworks such as Kubeflow, Airflow, and MLflow, and whatnot, and you get the fully managed infrastructure benefit of SageMaker. So it actually makes the process of actually model scaling to production really easy. And one of our customers since the early days is Netflix, who, when we were talking to them, and they have a lot of experience in scaling machine learning practice because their personalization algorithm is one of the best that runs in production. So, and they have built internally an orchestration framework that they have been using for a wide variety of problems. And they were actually interested in seeing how to actually, and they run on AWS, of course. So, and they were very interested in open sourcing their orchestration framework. And today, I'm excited to announce the open source project by Netflix called Metaflow. So Metaflow is a data scientist friendly Python library for machine learning on AWS. It has inbuilt integrations with Amazon S3 and SageMaker and Batch under the hood. Metaflow takes care of key ingredients such as production-grade ML workflows, such as dependency management, experiment tracking, and model versioning, and so forth. So, and data scientists can just use the notebooks and using a simple Python API, and they can actually train it on SageMaker. So please check out metaflow.org. And there is a separate talk, I think, on Thursday at 1:45 from Netflix. Highly recommend checking it out as well. So, with that, now let's talk about how do we make machine learning easier to apply. So this is the set of feedback where we heard from customers on how can we connect the dots more for customers who are trying to apply machine learning. And one of the areas that we heard over and over again was around search. If you look at the problem of search, enterprise, the World Wide Web search or the internet search is actually a well understood and reasonably well served market. I mean, with popular search engines. But nobody has done a good job of helping enterprises to make all their internal data searchable. So, and the reason is because, first of all, unlike the World Wide Web, where there are web pages with good markup languages, and actually they have linking structure so that you can do things like page ranking and so forth. Intranet structure is not like a well-connected graph. It's almost like a two-layer tree where there is a root and then a bunch of documents put in a file system or in a SharePoint or actually in a Dropbox folder and so forth. So, and this is one of the reasons why we constantly heard from customers, we spend more than 20% of our time looking for things. And 44% of the time, this results in loss in productivity. In fact, certain estimates say many enterprises lose up to like $5,000 a year per employee in terms of them not having the access to the information they need. And the reason is because this market is not well served so far is because usually this comes down to two challenges. One is, first of all, this data is unstructured. So there is very, very little structure between like a Word doc or a wiki file or a PDF and you name it. And traditional keyword engines don't really understand the intent behind the doc. They don't understand the context of the doc so that they can actually answer the question. And the second thing is complexity. Internal enterprises, data are spread across multiple silos. There might be docs sitting in actually SharePoint or Salesforce or Dropbox or file systems and so forth. So first of all, you need to build an ingestion pipeline, let alone then you have to figure out what are all the search results or the stale and so forth. This is the problem Kendra is trying to solve, where we rethought what enterprise search could be and where you can ask the question using natural language queries. It understands the natural language and it has the domain expertise, not just for simple queries like where is the ID desk, but it has domain expertise across like various domains such as pharma and oil and gas or you name it, various industry domains so that you can, as a customer, be able to deploy and find, it makes it easy to find what you're looking for and simple and quick to set up as well. Instead of me talking about what you could do with Kendra, we thought it would be great to hear from the voice of a customer. So I'm really excited to welcome Jillian, who is our Senior Director and Head of Cloud Engineering and AI, and an AWS Machine Learning community hero as well. Welcome, Jillian.
Thank you. Hi, I'm Jillian McCann from WorkGrid Software. WorkGrid Software is a SaaS startup that focuses on intelligent workplace products with the aim of improving the employee experience. WorkGrid is wholly owned by Liberty Mutual Insurance, which is a Fortune 100 company with over 50,000 employees across the globe. WorkGrid's origins start with an internal application that we built for Liberty Mutual back in 2013. And we launched this as a platform in 2015, with the overwhelming response from our employees was, "We love this." And you never hear that about enterprise software. So in 2017, we launched WorkGrid Software as an independent company with the aim of bringing to market the product that we brought to Liberty Mutual. So what was the problem that we're trying to fix? What do I mean by employee experience? Well, think about the complexity of the modern workplace. We have a multitude of systems that perform many different tasks. We have best-of-breed applications for expenses, HR, help desk, developer tools, collaboration tools. The list is endless. But think about the employee. You're asking the employee to navigate multiple systems to potentially only maybe leverage 10% of the overall power of a platform. We've had stories of customers, we have managers being asked to log in 6 pages into a website to click one approve button. So you think about the landscape. What we've seen was this digitization of processes has actually led to complexity within the workplace and context switching for employees. And at WorkGrid, we believe that enterprises are paying employees to waste time and frustrating them in the process. So what did we do? What did we build? So we delivered the WorkGrid Assistant, which is an intelligent workplace experience. It's a modern user interface that consolidates notifications, approvals, tasks, and messaging from disparate systems. It elevates communications outside email. It provides that single pane of glass. And relevant to this talk, it provides instant access to information and answers. Answers to questions, information retrieval, and also the automation of tasks, all through a natural language chatbot. One of the key things we did was we really focused on the experience, bringing a consumer-like experience into the workplace where we engage employees so they can use it on multiple different types of devices, anytime, anywhere, whether you're a desk worker or a frontline worker. So chatbots are everywhere, a lot of hype. What makes an actual good natural language enterprise assistant? In my opinion, it's more than one thing. And at WorkGrid, we try to iteratively improve across these 4 main areas. So tasks, these are goal-oriented, action-based conversations that usually mean integration into a third-party system. So think create help desk tickets, schedule meetings, take time off. But we also have to provide a level of intelligence. You need to provide personalized answers because an answer for somebody in one office is not the same answer potentially for somebody in a different office. And you need to have a level of memory because memory provides context. A conversation without the context is just random words. But also provide some entertainment. Provide some engagement with your employees, a little bit of personality, a little bit of banter. But importantly, another main part is knowledge. When I talk about knowledge, I mean answering your employees' questions, finding the information that they're looking for. You think about corporate landscape, there's corporate answers, the same for company-wide. There's domain-specific, job-specific answers. But importantly, and to touch on what was said earlier, most of the answers or most of the data exists in unstructured form. It exists in your text files, in your web pages, your audio files, and your images. So how do we extract that? And how do we bring that to the power of the assistant? Well, obviously, you use AI. AI in the workplace. So I think taking a step back, when we talk about bringing AI into the workplace, think about the different types, the different fields, And I think really having an understanding of the benefits of these different types really help lead the use cases. And you don't have to bring them all in at once. You can gradually, with the power of AWS, add these capabilities. And this is the beauty of AWS, is a lot of things on that diagram are available as AI services. So we've got Lex, we've got Comprehend, Transcribe, and Kendra. I mean, the list is large. But the one thing that I think is really powerful is also a lot of the advances there in SageMaker, is that if those managed services don't meet your use case, you can go that one step deeper, and build your models. And with the new capabilities, I think we're really seeing a lot more developers really engaging in that development role. So the sort of AI that I have been focusing on has been in the natural language processing space, conversational AI. So the NLU, the entity recognition, text classification. And with a voice assistant, obviously, you have the speech recognition. But to go back to that quadrant of knowledge and answering questions, as part of our product, we provide self-service capabilities for knowledge authors to provide curated answers. So we've gone into a journey of search engines and relevance engineering. And as I did that, it became very apparent of the similarities between chatbots and intent recognition. And this is where our interest in Kendra sort of sprung from, is how do we apply this machine learning to search? Because what we're trying to do is actually answer our employees' questions, not with links to another page, to another site, but actually the answer and that one conversational interface. So search is changing. We talk about like a conversational interface or a voice assistant. You don't just go to Alexa and say one word to it. You say a question, you ask it a question. And when you ask somebody a question, what do you expect back? An answer, hopefully the correct answer. You don't expect them to send you off to a SharePoint site. You actually want the answer. And that's what we're really trying to drive at with Kendra, is the ability to converse with a document in a way that, rather than being presented with a link, it can extract out the phrase or the sentence that answers your question. So I think the best way to see that is actually with a very simple example. So imagine a new employee. They've heard there's a gym at the office. I don't think they ever sit back and go, let me read the gym policy, the 40-page policy and what I need to do. They maybe have a few pointed questions. So what I'm going to show you is actually real results from a real internet search and the comparison with Kendra. So, what time is the gym open? This surprised me. It didn't. You can see the word gym is highlighted there. So this is very much your standard internet keyword search. It doesn't actually answer the question. And this is the Kendra version. So as you can see, it reached into that document and extracted out the paragraph. So from this, I can tell the opening hours, but it's also given more information. So this is really like there's a paragraph in that document that answers that question. So when you can imagine this combined with a conversational interface, you're not actually having to go anywhere else. You're in that one place and you're getting your answer. So maybe you don't know about gym etiquette. You want to just ask a question, should you clean the machines after use? So this is the answer that came back. And I'm assuming in this document there must be a mention of machine learning, because that was the only link I could think of between cleaning machines and artificial intelligence. Again, a real internet search, a real company. And there's Kendra. So apparently, after using a machine, you have to use sanitizing wipes. But if you can see that in bold there, that is the exact answer that we're looking for. So what Kendra does is really helps us with this goal of providing answers to employees and not links to other documents or websites, because all that data, the unstructured data, is now accessible. And we think combining answers with actions will really deliver true assistance in the enterprise. Thank you.
Thanks, Julian. Thanks, Julian. That was really interesting. I never expected cleaning machines has something to do with artificial intelligence. But that said, let's talk about actually writing software. So Andy touched on this in the morning about why we build CodeGuru and what does it take to actually build high-quality software in enterprises today. So the process of writing code in enterprises or in startups is pretty well understood nowadays. You actually start with writing code, and then actually, hopefully you get it reviewed, and then you then move to building and testing it, and then deploying it, and monitor the performance, and measure it, and then later make improvements on what you see in runtime. This process seems well understood and rinse and repeat. While this seems, well, it's almost like something that is a lot more robust, what we find, even internally, but also when we talk to many of our customers, is it's very difficult in practice. Why is that? It's because, once you write code, first, to even get a review, first of all, expert reviewers are hard to find. Irrespective of whether you're a startup or if you are like a big tech company like Amazon, the expert reviewers whom you really want the code review from, they are the ones that are in most demand. So they always take longer, not because they don't want to get to your code review request, but they just have so much to do. So, and moreover, even the expert manual reviewers sometimes miss critical bugs, such as concurrency-related issues or AWS best practices or security and so forth. The expertise that is needed to do a single code review may not always be with a single person. It might be with multiple folks. And let's say even you have actually gone through this step. The next step is once you build and test and run performance tests and so forth, one of the things we constantly find is that we have learned this over the years that in Amazon, that almost every application package we run, we call it like they have a set of what we call as the most expensive lines of code, which we believe is actually adding to most of our capacity issues. And if we optimize it, we could do better. So, but how do you go about identifying it? In reality, that means you really need like good runtime performance engineers who understand profiling and stack tracing and so forth. And even once you deploy it, you actually need to find out if the application characteristics change and evolve, how you are going to do it. So looking at all this, I asked a very fundamental question on, given there is a world where machine learning exists, how would you rethink software development using machine learning? So by this question was the beginning of the journey for us to build CodeGuru, where it's an end-to-end automated code review system and automated profiling system that identifies the most expensive lines of code in your application, but also does automated code review. So I talked about what CodeGuru, before CodeGuru, what writing software looks like. Now with this, it's pretty simple. Once you write code, you automatically actually get review feedback, and it suggests optimizations for performance and so forth. Now let's take a look at how do you set it up. It's pretty simple. As a repository admin for my code, I actually associate CodeGuru reviewer with the code repository. And then when a developer makes a pull request, means they're writing a few lines of code or actually a large check-in, CodeGuru reviewer automatically gets notified. And then it runs a bunch of machine learning models on the pull request and returns feedback in. And then developer actually gives feedback to say, hey, did we get it right or not? So now let's take a look at how it actually works under the cars. So let's take an example, something like a customer performs a pull request with a code that looks pretty simple. So, like with a nicely try-catch exception, they're opening a URL stream. And now with this source code, now the first thing CodeGuru reviewer does, it extracts the semantic patterns and identifies the graphs and then says, okay, hey, this is what this looks like. And then passes it to a series of ML models. which basically is built on actually more than 20 years of Amazon code base and code reviews and more than 10,000 open source projects. So we have a series of patterns that the machine learning models have picked up on common areas. So based on these learnings, it automatically gives certain feedback. In this example, it can be like, hey, there is a possible resource leak. So instead of actually just giving at a high level, what I thought I would actually give you precise code examples of customers that we worked with during the beta cycle on some of the code that has been running in production. And what did CodeGuru reviewer find? For instance, here is an example of a concurrency bug. Here, a code like this, it seems pretty reasonable that all you're doing is hey, you're doing and checking if particular thing contains some form of IP address and returning it. Now the issue is this may not be thread safe. And that is exactly what CodeGuru reviewer said. Hey, you have a concurrent hash map and you're using a contain key and get may not be thread safe. Instead, you might want to do this. It's pretty simple. And what used to look like a very hard to find, concurrency bug, now it is easy to catch at a review time. And developer feedback was, hey, good catch of a potential race. Now the flip side of concurrency is developers who are paranoid about concurrency, they actually end up over-optimizing or thereby slowing down performance. Here is an example of a developer who wrote the code about synchronizing at a meta level about an object. And then when CodeGuru reviewer saw this, it kind of said, hey, all you're doing is a get and a put. Why don't you change it to something like replacing put with put absent, put if absent, and then you can remove the synchronization altogether. So again, great feedback. Now, let's talk about pagination. So one of the common mistakes, especially when people integrate with cloud services, such as AWS services, they commonly make mistakes with programming against paginated APIs. Here is an example where somebody did a DynamoDB scan API. And they seem to have missed out that it is returning paginated results. So the reviewer gave this feedback saying, like, you might want to check, otherwise you have a correctness issue. So with this, it was very simple, this is right, and then they moved on. Now let's talk about security. This code seems like a very well-written code. You cannot find that much of an issue. So what is wrong with this code when you think about it? So it looks like they have done everything, they have caught all the exceptions and so forth. But the issue here is this. They actually had a get AWS account ID, and then when an exception happens, it will potentially log a sensitive information such as AWS account ID into an error log or access log. And this is probably not what your CISO would want if he ever got to review the code, let alone if he actually caught it. So, and this is one of the key things actually CodeGuru reviewer does. Essentially, it says, hey, you might have a potential information leakage here. So you might want to take a look at this and see what to do. So, and you can fix it something like this. So a developer who got this feedback as part of their pull request, he or she was so delighted that they gave feedback like CodeGuru is the best AWS service in the whole world. So, and I personally have built 40 AWS services, so I wasn't sure whether I should be really proud or I should be wondering like, what about other 39? So, but that's it. It is really exciting to see this kind of feedback. I mean, there is so much innovation that is possible with this one. So I'll stop here and actually say, we are really excited to make machine learning really easy to build, easy to scale, and easy to apply. With that, thanks again for coming. Really appreciate it.